Hello 108 class, Mr. McHugh back here with you on page 4 for section 5.1. We are going to talk about scientific notation here to wrap up this section here. Now, this is objective 6. Scientific notation was created by scientists to handle very large and very small numbers, and it's a way of writing numbers so that we take advantage of our numbering system based on factors of 10. As you move across the columns from 1 to 10 to 100, those you multiply by 10 to go to the left. Okay, so what's going on here now? Some of you, I'm going to make a suggestion. This is going to sound a little different than what you're used to here for this. Scientific notation is written with a number that's between 1 and 10. Now that part doesn't change. And time, this means times, the x means times. You're going to put the base 10 and you're going to raise it to an exponent that's either going to be a positive or a negative. Okay, now the challenge here is to convert from a regular number to scientific notation. That's one way to go, one direction, and then to go from scientific back to the regular number. Okay, now my recommendation is this, is that if you have your books, if you look on page 271, look for I'll call it the, oh geez, I don't know what color that is, I'll call it tan. The tan box says how to convert a positive number to scientific. You can look at those 3 steps to do that. If you look on page 272, you will see the other way, how to convert a positive number from scientific notation. Okay, to go back the other way. Now, my method here, when I learned these, I used to get confused. Once you get into here, everybody's is comfortable with the counting. I came up with what I call the clutch method. Now, if you are comfortable with scientific notation and you have a scheme and a method in your mind and you know it works and you're comfortable with it, you do not have to use the method I'm going to describe. Okay, now, you can't see my hands, but my hands are moving. My left hand, my right hand are moving back and forth as if I was working a clutch in a manual stick car. If you drive a stick, you know exactly what I'm talking about. If you're just an automatic driver, what you know is you've seen a car has a extra pedal. It's for the left foot, and that's used to push in the clutch so you can shift with your hand, and then your gas pedal comes out, and then as you go back in, the gas goes in and the clutch comes out. So there's this motion of in and out, in and out. Okay, now I finally came up with this scheme here because I used to get confused with which way do when I move the numbers and count, is it a positive or a negative? Okay, so I'm going to teach it this way. What I like about this method here real quick is once you learn how to use a couple aids to get you started with it, you don't have to remember if you're moving to the left is a positive or a negative with the exponents, because it switches depending on whether you're converting from numbers to scientific or from scientific to numbers. Okay, so let's go ahead and take on a case here of example 9, and let me describe to you what I call the clutch method. Okay, so here's the deal. Here's a number, 820,000, and they want you to convert it to scientific notation. Now, first thing you do here is you add this, you say times 10 to the 0. And the reason you do that is anything raised to the 0 power class equals, you got it, 1. So I am not affecting the value of 820,000, but it's helping me set up to use the clutch method. Okay, now they want the number to be between 1 and 10, and most students are okay knowing that here's the assumed decimal. I got to move it until I get to a point where I can rewrite the number between 1 and 10. So let's count. 1, 2, 3, 4. I'm moving at 5 places. Okay, so they moved it 5 places. Oops, excuse you. Don't put a plus, just put a 5 and circle it. Okay, now you write 8.2 times 10, and then this is a big, you put a 5, and this, whether it's a positive or a negative, is what we need to decide. Is everybody with me here now? Okay, now here's the deal. Work your clutch. On the left side is your clutch. Look at the number. You went from a big number, I'm looking at 820,000, I shrunk it down to 8.2. Went from a big number to a small number. That is working the clutch, pushing it in. Now you went from big to small. You look at the exponent. You wrote times 10 to the 0. That has to be from big to small. You now reverse it and write small to big. This is my clutch method, small to big, and you're looking at the exponent. That's what you need to accomplish. Now 10 to the 0, and you got to go to 10 to the fifth or 10 to the negative fifth. Okay, those are your two options. If I put a positive 5 in here, I go from 0 to 5. Am I meeting the requirement? From small exponent to big exponent? Yes, and you got it. Okay? If I had left the negative in there, I would have gone from 0 to negative 5 would have been what? Big to a smaller. Now don't forget on your number line, in case you don't get, here's 0, here's negative 5. Which one's bigger? The 0 is, because it's to the right. Okay, so that's how you work that. So you know you moved it 5 places, you know the exponent's going to be a 5, it's a question of negative or positive. Okay, now we went from a big number and converted it. Now look at example B. This is a very small number. Now watch the patterns here. Again, everybody's comfortable. You know you need to move the decimal so it's between a number, the new numbers between 1 and 10. So let's start counting. 1, 2, 3, 4, 5. Now, do I stop here? I'd be writing 0.72. The answer is no. I need to go here because I would be writing 7.2, which is just right. If I'd go one more, that would be 72, and that's too big. Think of the Three Bears and Goldilocks and the porridges and stuff. You got to move it between 1 and 2, so we moved it 6 places. Okay, 7.2 times 10. You write the 6. The question mark is it a plus or is it a minus? That's the big decision. Okay, now how can we make that answer for us? Some of you see this real quick. You're dividing, being negative exponent, but try the clutch method if you get confused with these. So look at the first number. I went from a very small number to a big number. Small to big. Reverse the clutch. So on the gas pedal, you got to go from a big exponent to a small exponent. So that's the key thing you need to know. Now, I forgot to tell you, don't forget to put your tool, your aid, times 10 to the 0. You need to add this in here to help you. Okay, now times 10 to the 0, you need to go from a big exponent to a small exponent. If I would leave this as a positive 6, would that match the requirement? No, because 6 is greater than 0. When I put the minus sign into it, I meet the requirement. Big exponent to a small exponent, and you got your answer. Okay, hopefully you guys are getting this. I'm hoping some of you like it. What's nice about this method now is we can go on to example 10 and start from scientific notation and write the regular number or standard numbers and use the same idea. Okay, so here's what we do. We turn around and we take 6.93 times 10 to the 7th, and this time the exponent tells you you're going to move it 7 places. Now if you know it's a plus or minus and you get comfortable memorizing them, that's fine. But here's what I'm going to do. I'm going to write times 10 to the 7th. My aid is to write times 10 to the 0. Again, because the 10 to the 0 is equal to 1. So I'm not affecting my final answer, but it helps me to start to see the clutch work. On the right hand side, the exponent, I'm going from a 7 to a 0. I'm going from big to small. I like to write this down, big to small. Then I come over to the number and I write small, and I need to go big. Small to a big number. Okay, so here's what you do. You write the 6.93, and here's the assumed decimal. Now you know you're going to move it 7 places. Think of coming up to a T intersection. Are you going to go left or are you going to go right? If I would go right, I would be writing 69. Is 69 bigger than 6.3? And the answer is yes. So keep going that way. Now how many places do I move it? 7. So you write 693, start counting. 1, 2, 3, 4, 5, 6, 7. Add enough zeros, then you write the time. Well, you already have times 10 to the 0 as your placeholder. So you write all the zeros out, count, move it accurately, and let's do it down here where you can see it. Here was the original, move it 7 places. 1, 2, 3, 4. Yeah. Oh yeah, there's a mistake here on my notes. Sorry. You need to go 69. Yeah, I didn't move it enough here. Let's do this right. 1, 2, 3, 4, 5, 6, 7. Wow. Okay. So your final answer here is 69,300,000. 69,300,000. Okay. So hopefully you think of that coming to a T-intersection and deciding where to move left or right. Once you know which direction to move, you count how many the exponent tells you. Let's try it again. This time, now look, this was a positive exponent. This example here is a negative exponent. Okay, so take your answer and write times 10 to the 0. That will not affect your final answer, but it helps you look at the clutch. You're going from -6 to a 0. So you're going from a small exponent to a big exponent. -6 to 0 is small to big. Come over and write big number to a small number. That's your goal. Okay, here's the 4.7. So you write the 4.7 and you know you're going to move it 6 places. The question is, are you going to the left or are you going to the right? If I would move it to the right, what would happen? I'd be writing 47. Is 47 smaller than 4.7? That is no. So I know I went the wrong direction. You turn around, come back to the original, and now you know you're going to the left and you're going 6 places. So draw yourself a bunch of zeros and then start counting. 1, 2, 3, 4, 5, 6. Final answer, 0.000047. Okay, so hopefully you like that method. It's optional. You can go ahead and look at the book. I'll let you read, and they do a great job explaining it too. I just like mine because it allows me to remember one process, and I don't have to remember the positives and negatives. Okay, now this is getting a little long here, so I'm going to kind of get going here on example 11. You notice the steps up here. It says you're multiplying. The reason scientists do this is if they have large numbers and small numbers, writing in scientific notation allows them to be more manageable with the calculations here. And so you're going to convert all the numbers to scientific notation. Step 2 says group all the numbers together and do the operation. Group all the base 10s together and take advantage of your exponent rules to come up with the calculation. So let me just kind of show this real quick. Here's example 11. Large numbers, small numbers, go through the process of converting them into scientific notation. Look, a large number, positive exponent. Small number, negative exponent. Negative exponent, positive exponent. Now, when you have that, the idea now is to take all the numbers and group them. 1.92 times 1.5 divided by 3.2 times 4.5. That allows you to do all that and crank it out on the calculator real quick. Okay? Then over here, what you've got is you're multiplying the same base and dividing. So you could take this real quick. An intermediate step would be, this would be what? 10 to the what? 6 plus a negative 3 is 10 to the third. This would be 10 to the what? A negative 5 plus a negative 4 is negative 9. Bring them on up, and your final answer would be times 10 to the fourth. Okay. Now, sometimes they'll tell you they wanted this final answer in regular format. Sometimes if they want it in scientific, it's got to be, the number needs to be between 1 and 10, so you need to move this adjustment, make it 2.0 times 10. So you're going from a small to big, go big to small, so I would take it down 1 and make it that answer. Okay, Mr. McHugh, I'm going to sign off. Sorry this was a little longer, but explaining that clutch method takes a little bit of work, so hopefully that helps. Okay, that's all for now. We wrapped up section 5.1, so I see you in the next one we'll begin 5.2. Okay, bye.